Hi, I'm Bill Wagner.
And I'm James Sturdivant.
Now once again, we're here to talk about object-oriented practices. Let's look at some of the things in the base class library that define and implement interfaces in such a way that they help make it easier for us to work with disparate types through a common contract. So we've got a couple different areas that we want to look at. One fairly large and one that's going to be a little bit smaller. So we're going to look at some of our collection interfaces. We're going to look then at iComparable, which we talked about quite a bit as we were going through the presentation. We'll introduce the lab that we can start to talk about the idea of creating your own interfaces and how that might work. Then we'll come back after that and we'll look at the solution to that initial lab. So let's start with that first big section where we have a number of different interfaces. Collection classes. There's a lot of different ways to work with collections of data in different contracts. So once again, I've got that core CLR project loaded in Visual Studio here. And I'm going to start with just that base core class or interface that we want to work with. It's called IEnumerable. One feature that a lot of people don't know about for a large solution, if I type it correctly, if I type a symbol name up in this search bar at the top of Solution Explorer, it will find all the instances of it anywhere in this particular project. You can see that some of them are classes that implement this particular interface. If I scroll down a little bit, I will see that I can get that IEnumerable interface definition. So we'll start by looking at that. There's only one. I grabbed the generic version, so we'll come back to that one in a later version. I want to not be in the generic section. I want to be all the way down here just in system.collections. We'll close these out, where it opens up everything that we saw. And we'll look at just the one that I want to look for, right there. There we go. So the IEnumerable interface has exactly one method, getEnumerator, which gets an object that implements IEnumerator. So if we look at that interface, IEnumerator has three methods. Move next to go to the next item in a sequence. It has a property called current that returns the current item in the sequence. And it has a reset method to go back to the beginning of the sequence.
So Bill, I noticed on the interfaces on the IEnumerator there were pretty straightforward to implement.
Right, and what's interesting is they separated this into two different pieces. One is an IEnumerable that says, okay, I know how to return an object that knows how to enumerate a sequence. And then the second one is that enumerator that says, here's an object that knows how to enumerate a sequence. So we've got these two different pieces. So what we'll find is the collection classes implement IEnumerable, and they'll do so in such a way that they return some kind of a private object, some class that they've defined usually as a nested class that knows how to walk that internal sequence structure. Right? So if I look at one of the classes that we looked at earlier, if I looked in our system.collections classes, and if I were to look and find our array list class that we were examining earlier. So if we go pull that up, and we'll look at an implementation of that. So if I look at array list, you can see that it implements iList. So I'm getting ahead of myself a little bit. iList extends IEnumerable. So we're going to have a getEnumerator method here that knows how to get something. And that returns this array list enumerator simple. And notice that its constructor takes the current object. And if we look at that array list enumerator simple, you can see it's an internal class embedded inside array list. Right, or it's a private class that implements IEnumerable or IEnumerator. It knows what list it's enumerating, and it has the methods for move next, for current, and for reset. So it knows how to, it's inside array list, and it knows how to enumerate an array list. So IEnumerable, we just have to return some object that knows how to enumerate this particular collection. An IEnumerator defines a common way for any object that knows how to enumerate a particular sequence of things to be able to do it. So we'll look at one other sample in the same way. String, as we said, knows how to implement IEnumerable for the string type. And this one I may search for a different way because I think string is going to get used a whole lot here. Yeah, if I go to toString, that's going to return a string. So hopefully I can F12 on this and find, there we go, the string class, as I said, which implements IEnumerable. So if we look at its IEnumerable implementation, we should be able to find underneath string, it's going to have a get enumerator. So we'll search for get enumerator. And we find that the implementation of that is going to keep going. Here we go. So here we see that implicit implementation or explicit implementation. We see it's defined as IEnumerable.getEnumerator. So only if I treat this as an enumerable, it's going to then return a new char enumerator, which again, it's an internal sealed class or a sealed class. And it knows how to get the current object. It knows how to move to the next character, or get the current character, excuse me. And then it knows how to reset itself. So two totally separate implementations, same names for the same methods. So we know how to put that together. IEnumerable, here's an object that knows how to enumerate this sequence. IEnumerator, the three methods, current, move next, and reset, I know how to enumerate a specific thing. And they're often implemented as those sealed classes inside the things that they do. Now, notice that IEnumerable and IEnumerator work together, and all you can do is walk a sequence from one end to another. So it's a relatively simple interface. And I sort of waved my hands a little bit when we looked at ArrayList because it implemented iList. So when we work through different things, we're going to want to say that, you know, there's more things I want to do with a sequence. So there's much more in there. So let's look at this from the other end. If I look at iList, which outside of the generic, I should be able to find the other collections to show me the iList interface. And we can see that this inherits from iCollection. And if we go to iCollection, you notice that it inherits from IEnumerable. So if I want to do a couple more things beyond enumerate a sequence, well, I have iCollection. It knows how to copy itself to some array or copy to something else. It knows how to tell us how many items are in the collection, right? A sequence may not be able to do that. It may just be reading input from a file. It doesn't know how, when that file will get closed. It may be reading from a stream or so on. And then we have this lengthy one for a sync route and is synchronized. So we know if some other thread might be looking at this collection at the time. And you can read the documentation for that. It's a way to allow for a collection to hold objects and be able to access them from multiple collections or from multiple threads safely in a read-only fashion. Well, so that's only a few more things. So that's a sequence, effectively. An iCollection is now a sequence that, well, knows how big it is and can copy itself out somewhere else.
And so here we're actually seeing the inheritance of multiple interfaces.
Right. So it extends IEnumerable. So it's still a sequence. We can still enumerate whatever the objects are in this sequence. But now we also know how big it is. Okay, so we've got that. Okay. And then if we have more different things that we want to do, then we get all the way up to iList, where now, first we have our indexer, so I can get an item at a certain index or set an item at a certain index in that particular collection. And a number of other methods. We've got add methods here. I've got a contains method to see if something is in a collection, right? And only some collections will do that. ArrayList does, but say treating an input stream from a network doesn't implement iList because it doesn't know if it's going to contain something because we may not have all the bytes yet. We can clear so we can remove everything. We can see if it's read-only. And then see if it's got a fixed size. That's a bit of a leaky abstraction that I'll get to as we look at a couple classes that implement this. And we can see if something's in the collection. If so, where is it? Insert and remove. Now this is where, some of these things get really hard. And even, as good as the BCL is, this is one place where abstractions are just a little bit leaky. We have this is read-only and is fixed size kind of thing. And if I look at array list, and we look for its is fixed size. I'm inside the enumerator at the moment. Let's go back up to just the array list itself. And if I look at its is fixed size method, we can see that it's just going to return false because it's not a fixed size. It knows how to add and remove items from it. So that means the rest of the methods that are part of this contract, they're all fulfilled. But as another one,
and so that's a great example of where we actually need to be able to implement all the various components of that interface.
Right. So now let's look at array. So arrays are fixed size, right? We can't make them grow or shrink. So if we look at its implementation of is fixed size, so it's now going to return true. And now because it's going to return true in this is array a fixed size, if you look at its insert method, it throws a not supported exception, right? So does remove. And so does ilist.add, if you can see, right? And once again, notice that these are explicit implementations of those interface methods. So the only way you get at those for an array is to cast an array to an ilist, and then you can see those methods. But even so, it is a little bit of a leaky abstraction, and it shows just how hard it is to try to get these common abstractions really factored out super cleanly. We've lived this throughout the history of the .NET framework. Most developers are reasonably comfortable with understanding how it's there. Some improvements were made a little bit in the interfaces for the generic versions, but it's still, it just shows how hard some of these problems are. And as we get to more advanced problems and more of the scenarios we come up with in our professional lives, the answers aren't always obvious, and we kind of hope to get as close as we can often.
Yep. And so I think, yeah, that's definitely one of those things where we got to balance getting these implementations correct and actually making and writing code and getting stuff out into the real world. Right.
There is one other important part as to all of these techniques is that shipping is a feature. We have to get to the point where we can get our code in front of our customers. We certainly want to do the best that we can. So with that, let's finish on a happier note. Let's look at that second interface, that iComparable interface, which is a lot cleaner. So if I look at iComparable, and here we'll, once again, let's try to find our definition of it. And right here in iComparable, you can see it has one method, compare to. So we get some other, so we compare to some other object. Is this greater than, less than, or if they're equal, or rather if they are equal in terms of an ordering relation, then it should return 0. Now if you look at Solution Explorer here, you can see that there are a large number of different types that implement this interface. Okay, and I've even closed up some of the ones under a couple of the other areas. Date time offset, for instance, I can compare to. And I can see, what time zone am I in, how far from UTC am I, and that will determine which one's greater or less than. I can look at the string class would implement iComparable.
And again, here you can see that the compare to function, when you actually go and look at it, it's fairly simple to implement, and you know it right away. Yeah. You know that you're going to be comparing with two strings. You're going to necessarily be comparing the way that you're working with them. So you might see a string, and you're going to compare make sure that they're the same length. You're going to make sure that they have all the same characters in them.
Right. So yeah, if we look at the compare to on string, which I just brought up as you were going through some of that description. So we can go to compare to, and it's going to look and see, all right, is this comparable? If not, we're going, is this a string? If not, then we're going to dive into this overload of this method that compares it to something else that's a string. We're going to go call their, we're going to go see if they're null, do some simple things there. Then we're going to see what kind of comparison. Are we looking at culture here? And then we're going to do different kinds of comparison helpers in terms of whether or not we're working with invariant culture, the current culture. Do we ignore case? Are we comparing based on upper and lower case? But the same contract exists. We can sort strings in any of these different fashions depending on how we want to do that comparison. Ints would do the same thing. If I want to look at int 16 or int 32, which should be down here somewhere in one of these classes. And we'll just pop one here. Let's see if we can get to that. There we go. So I have, it implements iComparable again. And again, if we can get to compare to, we can see that it's going to just go, okay, so is this null? Is it the same type? If so, let's just compare the values and return what our comparison is. So totally different types, same contract. We can use that ordering relationship on any algorithm in the BCL to be able to do things to put different types of objects in order, regardless of how they're put together. So now let's look at a lab and add some things in our class and learning institution area and work with some interfaces. So now let's introduce the idea of a teaching assistant. So a TA is a student, but also has some of the capabilities that a teacher has. They have a subject that they teach. They have a list of classes that they might work with, no more than 2, because we don't want to overburden our TAs because they are students. And now figure out how you would put that together. What would go into an interface that would allow us to treat a TA as both a student and as a teacher at different points in time? And where do we want to split out that interface versus that common base class that we put together earlier between the student and the teacher and that person concept? So how do we want to factor that commonality out in terms of being able to work with this new concept? And with that, we'll take a break. And we'll be back to show you the solution that we put together for this particular module and see how that compares to what you built. See you soon.